All right, you're here. I'm on number 9. What is the isotope symbol of the daughter nuclide if lawrencium undergoes electron emission? So lawrencium here has an atomic number XCA. Atomic number is 103, right? And the mass number is 256. Okay, it undergoes electron emission. So what does it mean when it undergoes electron emission? So that means it undergoes beta decay. You familiar with that? Beta decay. So what will happen if there is electron emission or beta decay? The neutron in the nucleus converts into a proton, so emitting an electron and the mass number stays the same, but the atomic number increases by 1. So we have here the atomic number, which is 103, increases by 1. It will become 104. All right. But the mass number of the this one, lawrencium, including the daughter, would be the same, would be equal to 256. Therefore, what's this? What's the question again? The isotope of the daughter nuclide of lawrencium 256-103 would just be, okay, 104, 256. So take a look at the periodic table. Which element is this that has an atomic number 104? Let's take a look at 104. If you can extend your, I have the periodic table here, like if I can extend there farther. Rutherford, do you have Rutherford in your periodic table? And what's the atomic number of Rutherford? How come? It's not 104. Number of protons, 104. So the daughter nuclide should be Rutherfordium 256 isotope, so 104, 256. But how are you going to answer that in your computer? What is NO? Is that the, yeah, because it doesn't have any question. So it should be RF 104. Can you still possibly input it in your computer? The RF? Because the ones you sent me are only screenshots, this one. So NO, you input NO, you were trying to say that the daughter nuclide is nubilidium before. So you change that to RF, and then the atomic number is 104. All right, because it increases by 1. Then we go to the next problem. Okay, can I delete this? No questions on this. All right. So when it is electron emission, that means beta decay, and then the number of electrons increases by 1. Okay, number 29, the one I downloaded. What is the mass of the second isotope if one of the isotopes has a mass of, okay, 165 atomic mass unit with relative abundance of 42%. The average atomic mass, average atomic mass is equal to, is that 167.00 AMU? Okay, so we are asked for the mass, to calculate the mass of second isotope. All right, but we're given here isotope 1, and the mass of isotope 1 is 165 atomic mass unit, and the abundance. So when we say relative abundance, it means how common this isotope is. All right, so it says 42%. So we can convert this to decimal, divide by 100. So this would become 0.442. So we want, this is mass 1, and then abundance 1. Okay, but we're given here the average atomic mass. To calculate for the average atomic mass, okay, we just add, or the summation of the masses times the relative abundance. So mass times the abundance, let's say that's F, plus the mass of the second isotope times its relative abundance. But first, we need to solve for the relative abundance of the second isotope. So relative abundance of second isotope is just equal to 100% minus 42%, which is 58%. And then we convert that to decimal, so that is 0.58. All right, so we plug in everything. We're interested to find the mass of the second isotope, so M2. We're already given here the relative, or the average atomic mass, which is 167 atomic mass unit. So we just plug in all the given values here. That one calls mass 1 is 165 AMU times 0.42, then plus mass 2 times 0.58. So we need a calculator for this. Okay, you want to help me solve this? Yeah. So that is 165 times 0.42. What did you get? 165 times 0.42. Yeah, try to calculate using your calculator. Okay, 69.3. I also got that. So we have 167 equals 69.3 plus 0.58 m sub 2. So we subtract both sides, or 69.3 from both sides. Then we have 167 minus 69.3. 167 minus 69.3, that is 97.7. So this one, no more space there. So that is 97.7 equals 0.58 m sub 2. So we divide both sides by 0.58. Then we get the value of m sub 2. Let me use another color here. So m sub 2 the mass of the second isotope is just 97.7 over 0.58. Divide 0.58. So I got 168.45 AMU. What did you get? Did you get the same thing? Abundance of second isotope, you just subtract, okay? 100% minus 42%. So the relative abundance here is 58%. Then the mass of the second isotope, like we did the calculation, that is 168.45. All right? No questions on this? Your voice is too low. Where is 167? Oh, from the given. It's given in the problem. Look, the average at the end, the last part of the problem, the average atomic mass is 167 AMU. So you divide it by 100 to convert it to decimal when you calculate for the average atomic mass. And this is the formula, this one. So average atomic mass is just equal to the summation of the product of the mass of the isotope, each of the isotopes, times the relative abundance. You're writing something? We move to the next problem. What is the average atomic mass of isotope 1? If isotope 1 has a mass of 34.1 AMU with a relative abundance of 42.9, and isotope 2 has a mass of 35.6 AMU with a relative abundance of 57.1%. Okay, so let's take note of the given values first. It says here that isotope 1, the mass is 34.10 atomic mass unit, and relative abundance, well, let's just denote it as F sub 1 is equal to 42.9%. And the mass of the second isotope is 35.60 atomic mass unit, and its relative abundance, let's say that's F sub 2, is 57.1%. So no problem. Okay, we're asked for the average atomic mass. Okay, average atomic mass. So again, to solve for the average atomic mass, we just add up the product of the mass, the given masses of the isotopes and their relative abundance. Okay, we need to convert this to decimal first. So 57.1 divided by 100, this is 0.571. Then the other one is 0.4290. All right, so what are we going to do next? We just plug in everything. So the mass of the first isotope is 34.10 AMU times its relative abundance, which is 0.4290, plus the mass of the second isotope, which is 35.60 atomic mass unit, times its relative abundance, which is 0.571. Okay, try to calculate this. Okay, use your calculator. We'll see if we get the same answers. Your answer here is correct, supposedly correct, but then you rounded off. You rounded it off, and the computer didn't accept it. So you have to take note that you only round off your everything when you're done solving everything, like only your answer. So what did you get? Yes, it should be 34.96 atomic mass unit. That should be the average atomic mass. Half-life. Can I delete this? Let's do the half-life. The half-life of cobalt-60 is 5.3 years. So half-life, T half of cobalt-60 is 5.3 years. How long will it take for a mass of sample is 79.7 grams. How long will it take for a 79.7 gram sample of cobalt-60 to decay down to 13 grams? Round your answer to 1 decimal place. So we will just denote the initial mass as m sub 0 or n sub 0. Okay, initial mass, initial is 79.7 grams, and then the final mass which is 13.0 grams. And then we are asked for the time it takes for 79.7 grams to decay down to 13 grams. Do you know the formula for half-life? Final mass? I just want to check if we have the same. Final mass equals initial mass times 1/2. T to the 1/2. I want to check if we have the same. Or you use K there. Yeah, because they... Is it the same as this one? The one I just showed you? This one? Is it the same as this? Okay. Or no, this is decay. Okay, this is decay. For half-life, it should be n over n sub initial 1/2 to the t to the t 1/2. How about that one? Is it the same as what your teacher taught you? The same notations? Because this is what I use. N the same or different? Okay, can you show me the formula that you use? 2 divided by n? How do you do that? Okay, can you show me? Can you write it down here? That would be strange if there is 2 divided by n. Or maybe 2n over n sub o. So we're given here the half-life. We need to solve for the time elapsed, right? Half-life is t 1/2, right? Or maybe t 1/2 equals ln of 2 over lambda, but we need to solve for lambda there. Okay, let me show you first using the formula I I wrote here, okay? And then we will use the formula U, because I don't get the T over N. It's not the formula for half-life, because we're given here the masses, this one, the initial mass and the final mass. So let's solve this first. So we plug in here we derive the formula first. So we divide both sides by n sub o, initial. So we get n over n sub 0, then 1/2 to the t over t 1/2. The 1/2 is the half-life. Now we can plug in all the values. Yeah, so n is 13.0 grams and n sub 0 is 79.7 grams. Is equal to 1/2. We don't know t, that's the missing, and 1/2, a half-life is 5.30. And then we get the natural logarithm, ln. So ln of 13.0 grams. Do you use ln? Oh, then ln of this. Okay, can you take a screenshot of the formula you have there and then send it to Preply? 1/2. So this is 1/2 t over 5.30. Yes, so I'm sure it will give us the same answers. So this is a screenshot of the formula that you were trying to show me. Just, yeah, show me that. So this is t over 5.3, then ln of 1/2. Okay. And I tried to calculate this on the calculator. I got 13.9 years. Oh, you got 14 years there. From your answer, you input 14 years and my answer is 13.9. It's just you shouldn't round it off to whole number. But what is n here? I'm curious, what is n? And it's also wrong. Number of half-life. So n here is t over t to the 1/2. So that would be 13.9 divided by 5.3. 13.9 divided by 5.3. So that is 2.62. You answered correctly. There's something wrong. You didn't talk to your teacher about this? Yeah, you calculated it correctly. It's just I think there's something wrong with the decimal places. So now, okay, t here, the time elapsed, should be 13.9. This is what I computed here. 13.9 years. But you answered 14. And now the n. That's a problem. Because my answer is the same as yours, 2.62. See? 13 point... let us calculate this again. ln of 13 divided by 79.7. Okay, then times 5.3 divided by ln of 1/2, which is 0.5. Okay, maybe 13.86. Okay, I will just put here, but it says 1 decimal place, so it's 13.9. Then divided by 5.3, because that is 2.61. It says 1 decimal place, so it should be 2.6 only. So you answered correctly. See, you answered correctly. Round your answer to 1 decimal place. So you should follow instructions. So n here is equal to t time elapsed over the half-life. So that is 13.9 divide 5.3. So it should be only 2.6 because it says round to your answer to 1 decimal place. Now you got it. No questions on this. Now let's move on to the next problem. Let me delete this. Okay, we're on the next problem. It says what percent of a sample of a radioactive element whose half-life is 5 years will decay after 44.7 years. So we're given the time elapsed of 44.7 years. Round your answer to 2 decimal places. Yeah, 2 decimal places. We're asked here for percent decayed, right? Percent of sample of radioactive element. So the percent of the sample that is decayed. So we use the same formula. The problem is the formula you're using there is different from mine. So this is what I use. We have what's that? 3 t to the t 1/2. Then we only compute the exponent here. We're given 44.7. This is 1/2 to the 44.7 over 5 years. What is this? 44.7 divide 5. So this is 8.94. N sub O, this initial mass. Then the N is the final mass. But we're not given here. Yeah. So we will not use that. We will only be interested in the percent decayed. So to solve for the percent decayed here, we compute this one only, this part of the equation, this one, the right part, the right side of the equation. Yeah. So okay, ln okay, we call that the remaining fraction. So that is 0.5 to the 8.94. I got 8.94 from 44.7 divided by 5. Then we use natural logarithm for this. ln of 0.5894. So ln of this is just equal to 8.94 ln of 0.5. Let's calculate this. If we get ln of 0.5 times 8.94. How come I? So this is negative 6.1967. Your n should be 8.94. That's yeah. Round your answer to 2 decimal places, but you answered 9. It should be 8.94. So how did you calculate this? Your calculation is correct. Okay. And then we raise this e to the negative 6.1967. This is how I calculate this. The e. So I got 0.00204. So only if we multiply this by 100, this is 0.204% of sample remains. Then we calculate the percent decayed. Percent decayed is just 1 minus 0.00204 times 100%. So I got 99.796%, or 99.80% of the sample has decayed. Your answer is correct. And the mass final, okay, we answered the same. No, I'm curious, how did you calculate this one? Can you show me your calculations or the formula you use? Troy, how did you solve this? Because you got the correct answers. It's just you didn't follow the instruction. It says round your... How did you answer this? Did you do the same thing like I did here? You calculate the mass okay. So no questions on this? You understood this well? Yeah, because I think, yeah, you answered this correctly here, except for your n. So n should be 8.94, because it says round your answer to the decimal places. So you're good. Now let's move on to the next problem, if you don't have questions. Okay, we're on, what's this, number 7? Fe61 has a half-life. So half-life of Fe iron 61 is 14.8 minutes. Okay. Of a 100 milligram, okay, mass of sample is 100 milligrams. How much will remain after 18 minutes? So we're given the time elapsed, which is 18.0 minutes. Round your answer to 1 decimal place. Your answer is even correct. So I got 43.1 milligrams. You answered 43.5. Yeah, but it's basically the same, right? Almost the same. It's just the computer didn't accept your answer, but you did good. And n is 18 divided by 14.8. Yeah, it's 1.2. So it should be 43.1 milligrams of iron 61. But you were right. You were correct. You didn't complain. Oh no, because you didn't follow the instruction. That means you don't have the right to complain about this. All right. Let's move on to the next problem. Okay. If the passing of 5 half-lives, so n here is 5, leaves 33.3 milligrams of strontium SR90, the initial mass, the final mass, because I denoted the mass as n, so let's just denote the mass as m. So it will be the same as your problem. So this is 33.3 milligrams. How much was present in the beginning? So we need to find the initial mass. Round your answer to 1 decimal place. So we use the same formula. This time I will just use the notation from the problem. So that is mass final, mass initial, times 1/2, 0.5, times n. We're given n. N is T over T, time elapsed over half-life. So this is 33.3. Then we don't have the mass initial, then 0.5 to the fifth. So 33.3 divided by 0.5 to the fifth. I got 1,000. I go. The initial mass is 1,065.6 milligrams. How did you get 1.1 milligram? So it should be 1,065.6 milligrams. So that is the original sample of strontium 90. So how many problems left? We still have one more, right? I think we've already solved like almost everything. So one more, only one more left. Okay, this one, the one with number 5. Okay, let's do this. All right. Use the two formulas listed in the performing the calculations below. Formula 1, that is n equals T over T2. This is what you were talking about, Megan. N equals T over T over 2. But when you have the final mass, you use the formula 2, or the formula I showed you, because n is just equal to T over T, half-life. T2 here is half-life, right? Formula 2, mass final, mass initial, 2 to the n. You or your parents decide to plan your future. After doing research on your investment, you expect your rate of return to double every 6.20 years. If you or your parents were to invest $8,697.3, what would the initial $8,697.3 investment be worth in 40 years? T is 40 years, or T2. It should be, because the notation here is capital T2. Assuming the same average rate of return, round your answers to 2 decimal places. So you take note of that, 2 decimal places. 40 years, and the doubling time is 6.20 years, right? And we're given the initial amount of investment, which is $8,697.3. We need to find the final amount. Okay, so we use the formula. So n equals T over T sub 2. So this is 40 over 6.20. So 40 divided 6.2, that is 6.45. 4516. We will just round that off later. And then for formula 2, that is m final amount equals the initial is 8,697.3 times 2 to the n is 6.4516. So don't round off values except your answer. Don't round them off yet. So that would be 2 to the, okay, what's that? 6.414516. Okay, times 8,697.3. What did you get? How come my number is really bad? I got 7, so the final amount is 761,225.2 decimal places, $72. Actually, you almost got, or you got the correct answer, because you answered there 760,375. It's 700,000, but the computer won't consider it, so don't round it off. You round off only your answer, your final answer. All right, so that's a lesson to learn. Lesson learned, Troy. Yeah, you don't round off like while you're still calculating. You only round off the final answer. See, you almost got it. So you got 760,000, and the answer is 761,225.72. See, you lost $1,000 in there in your investment. See, so don't round it off. You lost money, Troy. $1,000. You convert that to peso. It's a lot of money. Yeah. Now, okay, do you have questions? I think that's the last problem. Did you understand everything? All right, okay. So I'll see you on our next lessons. So if you need help for more problems tomorrow, then you can send me ahead of time. All right. All right, Megan, Troy, you have a great night. No, not night. Great day. It's my night time here. Okay. You have a great day. Bye.